Okay, stop everything you're doing right now because I need to tell you about something that's making astronomers lose their minds. There's a star out there, right now as we speak, that is literally impossible. And I don't mean unlikely or rare. I mean, it breaks every single rule we have about how stars work. It shouldn't be there. It can't be there. And yet, it is. When the lead researcher first saw the data, he thought his equipment was broken. He ran the tests again, and again, and again. Same result every time. His exact words were, "This is going to rewrite the textbooks." So what is this star? Why are scientists freaking out? And what does it mean for everything we thought we knew about the universe? Stay with me, because this is going to blow your mind. Picture this. It's 2018. A team of astronomers is doing a routine survey of the sky. They're using one of the most powerful telescopes on Earth, looking for interesting stars. You know, just another day at the office. And then they see it. At first, it doesn't seem that special. Just another faint point of light in a sea of billions. But when they start analyzing its spectrum, the light it's giving off, everything stops. The numbers don't make sense. See, when you look at a star's light, you can tell what it's made of. Different elements produce different patterns of light. It's like a fingerprint. And this star's fingerprint was wrong. The star is called SMSSJ 1605540.18-144323.1. Yeah, I know, astronomers are terrible at naming things, but the team that discovered it started calling it something else. They called it the star that should have never formed. Here's why. This star is almost entirely made of hydrogen and helium. Almost nothing else. No carbon, barely any iron, no heavy elements at all. And that's a massive problem. Let me explain why this breaks everything. When the universe began, right after the Big Bang, there were only 3 elements: hydrogen, helium, and a tiny bit of lithium. That's it. No carbon, no oxygen, no iron, nothing else. All the other elements? They were made inside stars. Stars are basically giant nuclear furnaces that crush hydrogen atoms together to make heavier elements. When massive stars explode as supernovas, they scatter those elements into space. Then new stars form from that enriched material. This means every star that forms should have at least some heavy elements from previous generations of stars. It's like a family tree. Every new generation inherits something from the ones before. But this star? It's like finding a modern human with absolutely no DNA from their parents. It's impossible. The star is old, really old, probably over 13 billion years old, formed when the universe was just a baby. But here's the thing. Even the first stars that formed after the Big Bang should have died long ago. They burned too bright, too fast. Stars this old and this pure shouldn't still exist. And yet here it is, just hanging out in our galaxy like it's no big deal. When this discovery was published, the astronomical community went into overdrive. I'm not exaggerating when I say scientists were freaking out. Research teams from all over the world started pointing their telescopes at this star. Papers started flooding in. Conferences were held specifically to discuss this one star. Because here's what was at stake. If this star exists, then our entire understanding of stellar evolution, how stars form, live, and die, might be fundamentally wrong. Think about that for a second. We've been studying stars for hundreds of years. We've built incredibly sophisticated models of how they work. We can predict their behavior, their lifespan, what they're made of. It's some of the most solid science we have, and this one star threatens all of it. But wait, it gets weirder. As more teams analyzed the star, they found something else that made no sense. The star's mass is wrong too. It's too light. Stars this old should be more massive. This one is only about 0.8 times the mass of our Sun. How is it still burning? How has it not run out of fuel after 13 billion years? One astrophysicist I read about described it like this. It's like finding a car from 1920 that's still running on its original tank of gas. It's not just improbable, it's physically impossible based on everything we know. So scientists did what they do best. They started coming up with theories, wild theories, desperate theories. Theory 1. Maybe this star formed in an incredibly isolated part of the universe, somehow avoiding contamination from previous supernovas. Problem: we can't find any region of space that pure. Even the most isolated areas have some heavy elements. Plus, how would a cloud of pure hydrogen and helium even collapse to form a star without the cooling effects of heavier elements? The physics doesn't work. Theory 2. Maybe this star didn't form naturally. Maybe it's the remnant of a much larger star that somehow lost most of its mass. Problem: we can't find any mechanism that would strip a star down like this while leaving it intact and stable. And there's no evidence of any surrounding nebula or material that would indicate mass loss. Theory 3. Here's where it gets really crazy. Maybe this star formed from material that was somehow protected or isolated during the first generation of star formation. Maybe it's hiding in a region where the laws of physics work slightly differently. Yeah, you heard that right. Some scientists are so stumped that they're wondering if the laws of physics might not be the same everywhere in the universe. That's how desperate things have gotten. Now, if this was the only impossible star we'd found, maybe we could write it off as a fluke, a cosmic anomaly, a glitch in the matrix. But it's not the only one. In 2019, another star was discovered with similar properties. Then another in 2021, and another in 2023. We're now up to about a dozen of these impossible stars, and each one is just as baffling as the first. They're all old. They're all metal poor. That's what astronomers call stars without heavy elements. And they're all still burning when they should have died billions of years ago. But here's what really keeps me up at night. If we found a dozen of these stars, how many more are out there that we haven't found yet? Our galaxy has hundreds of billions of stars. We've only closely examined a tiny fraction of them. What if these impossible stars aren't rare? What if they're actually common, and we just never looked carefully enough before? And here's an even crazier thought. What if every assumption we've made about the early universe is wrong? The Big Bang Theory relies heavily on our understanding of how the first stars formed and died. If that process is different than we thought, it could change everything about our cosmic timeline. Now, some researchers have started proposing something that sounds like science fiction. What if these stars are powered by dark matter? I know, but hear me out. We know dark matter exists, or at least something with mass that we can't see exists. It makes up about 27% of the universe, and we know it clumps around galaxies and clusters. Some theoretical physicists have proposed that dark matter particles, if they exist in high enough concentrations, could be captured by stars. And when these particles collide and annihilate each other, they release energy. What if these ancient stars are being kept alive by dark matter annihilation in their cores? It would explain why they're still burning after all this time. It would explain their unusual properties, and it would finally give us direct evidence of what dark matter actually is. But here's the problem. We'd have to completely rewrite our models of stellar physics to include dark matter interactions. We'd have to admit that stars are way more complicated than we thought, and the implications would be enormous. If stars can be powered by dark matter, what else can dark matter do? Could planets be warmed by it? Could it affect the formation of galaxies in ways we never imagined? Let me take you deeper into why this is such a crisis for astronomy. There's something called the metallicity floor. This is the theoretical minimum amount of heavy elements that a star should have. Even the oldest, most primitive stars should have at least a tiny bit of carbon, oxygen, and iron from the very first supernovas. Scientists had calculated this floor based on supercomputer simulations of the early universe. The models had been tested, refined, and confirmed by countless observations. The metallicity floor was considered one of the most reliable predictions in all of astrophysics. These stars are below that floor, way below. It's like discovering water that's colder than absolute zero. It shouldn't be possible. The math says it can't happen, but it is happening. Dr. Anna Frebel from MIT, one of the leading researchers studying these stars, said something that gave me chills. We've found the edge of our knowledge. Beyond this point, we're in completely uncharted territory. Think about that. These are people who study the entire universe for a living. They deal with black holes, neutron stars, galaxies billions of light years away. And this one type of star has them completely stumped. Okay, so why should you care? Why does it matter if some stars shouldn't exist? Here's why. Every time we've discovered something that doesn't fit our models, it's led to revolutionary breakthroughs. When scientists found that Mercury's orbit didn't quite match Newton's predictions, it led to Einstein's theory of relativity, which gave us GPS, nuclear power, and our understanding of black holes. When quantum mechanics revealed that particles behave in ways that seem impossible, it led to transistors, lasers, computers, and smartphones. These impossible stars are telling us we're missing something big. Maybe it's dark matter. Maybe it's a new type of physics. Maybe it's something we haven't even thought of yet. But whatever it is, when we figure it out, it's going to change everything. We might discover new forms of energy. We might find ways to detect and use dark matter. We might unlock secrets about the birth of the universe that we never dreamed possible. And there's something beautiful about this too. In an age where we sometimes feel like everything has been discovered, where science seems settled and boring, these stars are a reminder that the universe still has mysteries. We're not even close to figuring it all out. Right now, as I'm speaking to you, there are telescopes pointed at these stars. The James Webb Space Telescope is examining them in unprecedented detail. Ground-based observatories are tracking their every flicker and fluctuation. Scientists are racing to find more of these stars, to study them, to understand them. There are research teams in Australia, Europe, the United States, Japan, and China, all working on this problem. Because whoever figures this out, they're getting a Nobel Prize, no question. But more than that, they're going to crack open a door to a new understanding of the cosmos. They're going to show us something about reality that we never knew before. And I think that's incredible. So the next time you look up at the night sky, remember, scattered among those points of light are stars that shouldn't exist. Stars that are challenging everything we thought we knew. Stars that are keeping brilliant scientists awake at night, scratching their heads and going back to the drawing board. The universe is full of impossible things, and these stars, they're proof that we've still got so much to learn. Before I go, let me leave you with this thought. If stars can exist when they shouldn't, what else is out there that we think is impossible? What other laws of physics are waiting to be rewritten? If this video blew your mind, smash that subscribe button because we're diving deep into the mysteries that science can't explain. Drop a comment and tell me, what do you think these stars really are? Are they powered by dark matter? Are they evidence of new physics? Or is the explanation even stranger than we can imagine? I'll see you in the next one. Keep questioning everything.